Today's video, we've got the Pro Spot machine that we have. This is a squeeze type resistant spot welder. Awesome tool. Some of the major benefits you're going to have with this thing is going to be factory OEM looking welds, as well as the strength of the weld that's included with that. Amazing corrosion protection, the ability to weld through not just a weld through primer like between flanges, but actually be able to weld through adhesives as well. Be able to weld through multiple layers of steel at one time too. So this is honestly, of all the tools inside of this, like our program shop here, this is my favorite one. It's so much simpler, so much easier. Cleanup is easy, tear down is easy. It's an awesome machine all the way around with it. So a couple of things that we need to analyze throughout this. This machine has two-sided welding capabilities, which is what we just talked about. This is what we're going to be showing today. It also has one-sided welding capability. The problem is with the one-sided welding capability is no OEM actually stands behind or supports that. It's got a lot of different little tools that comes into it too, and you can weld nuts on and whatever else. But this is hardly ever used for us here in the shop. It's always going to be this two-sided welding scenario that we have there. A couple things to note is we actually have, let's go up a little bit, get a little bit closer here. So we're going to have our two-sided welding clamp that's inside of here. Something important to note is you can see that little kind of, move my hand, kind of lock that's inside of there. That's meant to catch on and hold this guy in there. So never just kind of loosely throw it inside of it. You need to make sure that it's locked inside of there. We have a variety of different clamps. You see one of them that's here. We're going to talk about that here coming up. You also see a variety of them that are down through there. 90% of our clamps are going to utilize this straight shaft with the blunt tip on the end, or the welding tip on the end of it through there. But whenever we get to this Et style one, that will change up, and we're going to have to change, where did he go? We're going to have to change the end to this triangle setup one that's there. You can see inside of there as well a variety of tools, replacement tips, shunting clamp, which we're going to talk about here coming up, a variety of different tips and things that are inside of that. Before we get too crazy, let's talk about basic startup on the machine. This machine here has a singular breaker. This breaker here just flips up to an on position, which you can see right inside of there. So we turn that on. This is operated with air over hydraulic power, so we also have to hook up an air supply in the back through there. It's going to be a three-phase power supply. So inside of our shop, we've got a three-phase outlet that hooks up inside of there. We've got another one that's way over there, kind of by the IWAR station, and then finally one that's over there by that welding booth across the way. So the only three places we can actually hook up this machine with our three-phase power that's there. Going into the setup. So this has an awesome setup inside of it where it says start welding. This is if maybe I haven't used it. Okay, first it's going to prompt us to log in. The login on all three of our machines is always going to be 1. We push done. Okay, so as we come into here, what's really cool about this is we're going to have what's called a pre-weld checklist. And this is going to take you through everything from lining up the tips, understanding what's a good tip and a bad tip that's inside of there, which really equates down to, let's show you one right quick. If you look at the end of that tip right there, that's going to be a 6mm diameter kind of circle or flat spot that's right there on the end. That is what we're striving for. If we get more of a tip that's like this, that's been overused, overheated, never cleaned enough, this can actually grow to 8mm, 10mm, even on some that I've seen in diameter. If you try to go through and weld with this, you're going to make bigger than a 6mm diameter weld, which in turn is going to be robbing from your power and sacrificing the quality of your weld that's inside of that. So good tip maintenance, which we'll talk about here coming up, is going to be necessary to keep a really nice weld, really consistent weld that goes through there. Okay, if we push next, I was talking about tip alignment, gaps that are inside of that, going through multiple layers, just an awesome little setup that I even like to, especially if it's been through the summertime and I come back here, I'll go through the same setup as well just to make sure. Now getting logged in, you can see where it says this login ID. We're going to go to 1, done. That's going to be for all the machines. If we go just up to 1, that is the login for every one of our Pro Spots here at the school. Why they have that is you can actually document, like, you could log in per technician. So say maybe my number was 0011. I could actually log in as a documented technician on that to consistently, it shows my welds consistently. A Couple things. We got a lot of things to look at here. Let's go with the first thing, which is going to be a variety of different options for welding that we have. So we have our material welding. We have high strength steel galvanized, basic mild steel, weld bonding, which is whenever we include adhesives with that, boron steel, pulse mode. Pulse mode is whenever we get into multiple layers of metal. So instead of it just being 2 layers we're welding together, this can have 3, even 4 that's inside of it. OEM is going to give us options on OEM vehicles that this machine already has prompted into it. This is one of the biggest complaints with the ProSpot i4s is not enough OEM really pre-programmed in programs that are there. This is something where newer versions of ProSpot or even GYS just really outplay the i4s that are there. And then custom, which we've never gotten into. So let's go over. You see where it's going to go over? This one's highlighted black. We go over, and now we're on mild steel. The next part we're going to have to go to is going to be right up here. It says program 0.7 millimeters. Now, you're seeing it in millimeters. The way we're traditionally going to look at it will be in gauge. So we're actually going to have it in gauge. And looks like my sign has fallen off. I usually have a sign that's inside of that. I get a new one that's there that actually specifies millimeters to gauge that's there. So I don't know why this one lost it for some reason, but we got to get one back on it. I usually put them inside of here, sometimes on the side. So I say, I'm not sure. Anyway, though, 0.7. Now you're going to see me push the up button. You see Nets program up button. It goes to 10, 12, 15, 20, 25, and then back to 17. So let's say, okay, I want to go to 12. I can't push this button to go down. That's not the way that it works. This takes me into save program. I'm not doing that. If I need to go back to 10, I have to go all the way back through it again. Now, I actually want to be at 12 because the metal thickness that I'm welding today, that's what it requires for me on that. Mild steel, 12. I've got one more thing I need to check, which is going to be right down inside of here. You see this pressure gauge. It goes 80, 85, 90. The range on this machine will be programmed at 80 to 90 PSI and go back to whenever we did startup procedures. It will tell us that specifically too. So we have it at 90. There's nothing the matter with that at all. We're perfectly happy. The last thing to cover on this part of the machine through here is going to be the actual water and cooling system. You see it turned on. This does creates a lot of energy, which creates a lot of heat as well. It has a built-in cooling system, kind of similar to like a radiator on a car. I never turn this off. Even if I'm turning the whole machine off, I always leave the water cooling system on. You should do the same as well. So let's start off. Let's actually get into kind of prepping conditions and everything else that's there. As we look inside of here, let's first just analyze the conditions of the tips that are there. Good tip conditions that are inside of that. If this was to have a little bit of debris on it, something we're going to talk about is constantly cleaning. A piece of 320 grit paper. I'm not trying to sand the coating off. I'm just trying to take any debris that might be on it and take that cleaned off with that 320. I call it more of a polishing cleaning than actually removing anything with that. Okay, so we got that through there. Now let's practice our alignment. 2 buttons on here. This button, if I push it on top, it's already pulled back all the way. Sorry, let's push this one first. This button on bottom goes in. So let's see it. We push the button, it goes in. Now, if I push the button on the top, it's going to pull it back inside of there just like that. What I need to do is check alignment of those tips. Those tips have to be perfectly aligned throughout that. We're going to step back and look. Both angles of it, we should be good inside of that. So, good to go here. Let's start talking about our metal. I got just 2 random pieces over here. This is going to be a 22 gauge metal. This one here specifically is 22 gauge that's inside of this. To make a practice weld, always have the metal clean. This one here still has a zinc coating on. I actually wanted to do that for this demonstration specifically because I want to see if it's going to throw sparks. If I'm throwing sparks, it means my tips are contaminated or my steel is contaminated. So even though this looks clean, that zinc coating can actually cause this to have basically a backfire on it. So let's see if that's going to happen with it whenever we do it. The next most important thing is going to be this clamp. Although it looks like a pair of normal vice grips at first, notice these tips that are there and notice this wire. You'd be silly to call it a grounding wire, although it looks like it. What this wire is doing is providing a complete connection from this side of the steel to that side of the steel that's through there. So let's look at that clamped up right quick. So it's not a grounding clamp. It's providing me a clean connection all the way around to both sides through there. Why do I need that? Because I need to make sure that whenever I make a two-sided weld, both sides of that have a good bond that's going to occur with it. Shunting clamp really only needs to be used on the first weld. The only time that's going to change is if I'm in the perimeter of like a door opening that's there. If I'm going to do this corner and okay, I want to get one established here, I'll move that shunting clamp around. The best way to try to imagine it is how far does if I had to keep it in simple terms, how far would my weld have to travel until it reached that first weld and get it around? I try to not let it exceed more than 6, 8, 10 inches that's inside of that. So if you're going from one side of the door all the way to the other side of the door opening on the rocker flange, that's going to be a problem. Keep that shunting clamp there just in case. It doesn't hurt anything. We just don't need it all the time. This is also should never be supplemented to be a vice grip. That's not what this purpose is. This is not a vice grip. It is built for connection. So don't try to be using this for your mock-up either whenever you get to that. Okay, what else we have through there? We got our tips clean. We got alignment done. Shunting clamp on. I think we're about time to make a weld that's inside of that. Everything's set up on the screen through there and happy. So I'm going to do this with just me here. Safety glasses, not just on, but push them up tight to the bridge of your nose in case a spark throws out. You don't want one throwing up underneath. So we're not sitting there holding it professor or librarian. We need to get it pushed all the way up and tight that's there. The next thing I'm going to do is get my metal lined up. Let's actually flip that around. There we go. To where I have it like that. Now, if I pull this trigger to go in, I can let off. So maybe I'm not in the right place that I want. I just let off. I pull it again. Oh, there we go. That's looking better. Now I pull it and I hold it. And at that point, the machine's going to take over and actually complete the weld that's there. This thing's also going to prompt us with a success rate that's there. Now, I talk too much putting that thing away, and I actually missed what it said through there. So let me know what it says. We shouldn't take anything less than 90% that's there. Generally speaking, if I have my metal perfectly clean, my tips are clean, everything's properly aligned, you should see a consistent 98, 99, even sometimes 100 that's inside of that too. So anywhere in that realm is going to be good. If the weld fails, so let's go here if you can't see it up close. You see where that screen's back to where we started. If a weld was to fail, it's going to alert you and say, hey, this weld failed. You have to accept and confirm that you understand that weld failed. So even if I didn't necessarily see what the success rate was on it, I know that it at least passed inside of that. This is where it's nice having a group that's here, because you can often have one person getting one person holding the machine, another person helps support, sit this down, another person helping to support this immense amount of wires, a lot of cooling hoses that go through there. There's a lot of weight that's on there. So one person hold and operate the head unit, the other person helping support that, and often a third person that's here that can actually monitor success rates as we're going. So let's check out the weld as a whole. We take our shunting clamp off, and there we have it through there, a pretty little weld that's going on. I can still destructive test these. I probably won't do it in this video, but there is destructive testing processes that are here with this too. If you're used to I-CAR would have this clamped and you would twist this over. This is actually the opposite. This would be clamped in through here, and I need to peel it off, kind of like what an old style soda cap would be. I need to actually peel this through, and it's left with a tail that's behind through there. So if we see that, that's a successful weld that's inside of it. So let's make another one right quick. So you notice I don't have the shunting clamp on it. I don't need the shunting clamp on it. My connection is now being made side to side through that weld. Now, I don't want to get past 10 inches away from that weld. I don't want to sacrifice my integrity of it. But that right there is enough for me to go to the next one. So we see it. We get set with it right through there. Let's put it around. Let's make another one. Okay, on that one there, 99% is what we showed on success rate with it. The cool part with it, I can put my hands right on that. I'm sure as heck not doing that with a plug weld that reaches almost 500 degrees Fahrenheit. On average, this is 74 degrees is what it is. So no heat effect zone that's going into it whatsoever. Another amazing benefit to having a squeeze type resistant spot welder setup. Okay, let's look at whatever else. We've made a couple welds. Let's inspect our tips and see if there's any debris that's there. So I'm going to push that button, which opens it up farther. Sometimes I'll just take my hand and rub it through there, and that gets a little bit of debris out. But once again, I have my 320 grit sandpaper. I can also just take and polish that guy through there with no worries at all. How about we switch this head? Let's get rid of this head. All of these style heads on the Pro Spots are very simple to do because this handle right here is also the tension lock that's on it. So you see that guy getting looser. I loosen him up and I pull him off. Now, my pet peeve is throwing these things down there in a mess like what's already done. Sit it down there nice and proper and organized inside of it. It just makes it 10 times easier whenever you're using a million different styles of these heads throughout your welding process. So a bedside may take 3 or 4 of these different guys that are through there. Especially you see this big long one that goes through there. That guy's amazing. We've got a medium-sized one, a smaller one. Each thing has its own purpose. To keep it organized down there so you don't have that problem. I'm going to turn the machine sideways to film this next part. Okay, so as we look inside of here, this is that etch style pattern that's there, a cross style pattern, and you can see an immense benefit that's there. So this one just pushes straight out and has to make a 90-degree contact. This one can actually get through and kind of scissor mount, or whatever I want to say that through there, I don't know. Get on either side of the flanges and make contact in a etch motion that's there. But to do that, I have to have a proper collar fit on that. This is where that straight shaft has to go. I cannot use the straight shaft style on that cross style attachment that's there. So I'm going to let it out just a little bit. And you're going to see specifically right here. Now you see some little bit of kind of marring and stuff. I'm going to put a vice grip right there and a vice grip right there. There is no need to go through and try to horse torque those vice grips on there. But you can also cause damage if you don't do them tight enough either. So snug, I think, is the best way to try to describe what I'm saying there with that. But I make a connection there on that housing, and then I make a secondary one on this shaft. I try to never do it on the tip itself, but rather keep it right there on that longer part. Now, see if I can get you set up a little bit different through here. This isn't that complicated. I'm going to try to do it with both these hands here. It's just a light twist back and forth, and that piece pops right off through there. And then we release them, put them back in its proper place on that shelf there. And now we need to get our next one out. So now you're going to see this more kind of cone-styled one that's through here. This is what needs to go on. It's got that blunt end that's going to go right back inside of where we just took the other one off. You don't have to try to like beat it on or anything like that. Just put firm pressure on it so it stays in its place. 2 things. We've got the handle here that's going to create that tension fit, but we also have a sliding collar that you can see there. That's what's actually going to go over that kind of triangle piece that's inside of that. Okay. So I'm going to start by slipping this guy. I can't get him all the way on there, though, until I start putting this sleeve collar on there. So now that I've got him there, I'll twist that on tight. You can see I need to pull this collar back and push him on into that place. You see that collar lock in? Now we don't have him snug on there. We're going to show you how to do that here right quick. But we're held on to the actual triangle piece that's there. Now what I need to do to make sure that guy gets pressed in tight is just pull the trigger. And whenever I'm doing that, I'm watching for the alignment of my tips, both that way and that way so I can see it. And just like that, we have that guy set up and ready to go. Now I can go through and weld these 2 pieces together. We don't need the shunting anymore. We already got our shunting done. Shunting's just done once unless we're moving more than 10 inches away. I like to put it on there then. So let's go ahead and make that weld. Top button goes open, so I could always get reset. I'm going to pull that trigger again. Oh, I don't like where that is. I just let off. Pull and hold. It completes the weld. It will release on its own. And we had 99% success rate that's on that. You can see why I love this machine so much. I really can geek out about the whole thing with it because of how efficient it is. It takes really pretty much all of the possibility of technician error, like what a plug weld could have, for instance. Maybe my arm moves too much and my plug weld gets out of place through there. Maybe I don't complete my weld all the way around. This thing doesn't have that issue. It just makes a perfect weld every time. That doesn't mean that we shouldn't test the weld, though. Before I go weld on a car with a plug, just a general MIG welder, I'm going to do test welds to confirm in a vertical position, I can make this weld. In a overhead position, I can make this weld. Why would I not do it with this? Human error can still occur, though, if I don't set the machine up properly. Better yet, if I don't verify the setup of that machine properly. So I am going to include in this last video bit how to destructive test one of these. Now, I can't destructive test this one because it's got 3 together. So I'm going to make another one right quick, and I'll meet you at the vise. Okay, so we're over here at the vise, and we need to destructive test one of our spot welds. There's a difference. Spot welds to make sure we have that done right. What I'm going to do is you're going to see me slightly bend this up to separate these 2 pieces that are here. And I'm going to get that guy, the bottom one, clamped up inside of there. So you can see me get him pushed down inside of there. I'll do a side view for you just so you know what I'm talking about. Bat side piece clamped up inside of there. Twist him down tight, push that guy down flat, and now I need to peel this piece back. Now it's going to be hard to do that by hand. Let me get a pair of vice grips right quick. Okay, vice grips obtained. Grabbing onto the top piece that's here, biting it tight. Now I like it, see where that head's kind of rounded? I like where I can grab that and actually use that rounded head to help peel that. Try not to smash my fingers here. There we go. Okay, so what we're going to see how that didn't tear out like a traditional type plug weld, how it tore kind of that tail, that pop can style, like soda can style tear of the old soda cans. And we see that hole torn through there, and we see where our our spot weld stayed exactly where and how he needed to be. There's no deformations around it. I can go and open up that vise. Let's check the bat side, make sure there's no deformations on it. We're good to go inside of there. This can be done with just a simple setup like weld through primer that's on there, tear it off. This can be done the same with adhesives that are there as well. The biggest advice I give to you is we need to mimic the location of the weld. So let's just say that's my weld area. I need to mimic that location by having adhesive between the 2 joints, but by no means should you go and put adhesive all the way across it to the edges. We don't need it, and it just creates a mess while destructive testing. So if this is my immediate weld site, put my adhesive inside of there, sandwich the 2 together, weld through them, and try to keep your mess minimal that's there. Final steps to finish this up is how do I properly shut this machine down. First, make sure that we've got, I don't want any test coupons inside of that, get rid of them. Make sure I've got my shunting clamps. Now those vice grips that I use to take those tips off, those don't go in there. Those go in the tool room. So make sure they're put away. Everything's nice and tidy. We don't want to leave just a loose end out. Let's put him in the bag. Shunting clamps there. Shunting clamp is clean, especially if you're doing any type of adhesive bonding inside of that. Make sure there's no adhesive left on those ends that's there. Close the lid. Make sure my tips are clean. I'm not leaving a mess for somebody else. If you want to leave a styled head on there, I'm fine with it, but not these big ones. Not that guy across the way, not this big one through there. They're just too big and too heavy, too bulky to be able to stay on here and stay in the stand. So none of these big guys. Take them off. If you want to take the head off completely and just leave the tool, that's fine too. We need to let this machine run. So say I just finished welding, 30 seconds ago. Don't come and just turn the machine off. It needs to keep it cooling. So right now, it'd be like running a car hard and leaving it, turn it right off, at 220 degrees. Let the car run. Let the cooling system circulate throughout there and properly cool the machine down. That's exactly what we're doing with this guy. 10 minutes minimum. If you've done a ton of welding, so let's say along the way, I recommend 15 minutes. So basically, while you're cleaning up the rest of the mess with your bedside or rocker panel, whatever, let this guy cool down. To turn it off is very simple. All you do is turn the breaker down and you're done. I never turn the water cooling system off. Always leave it on and just turn it off with the breaker. Why do I do that? It's so that students don't forget to turn it back on. It's a vital tool with that too. Turn it off though, unplug my air supply that's back here and pop him off. You see where I have my 3-phase coil wire at, my wire, however I'm trying to say it here, my wire roll, whatever it is. Pop the plug off, roll it up in a tight loop, and there is my hook that's there. I don't know why I couldn't think of extension cord, but extension cord is what I mean. Hook it on through there, and then the last piece of the puzzle is going to be putting on this Pro Spot cover that goes on that through there. There is a top loop that goes through here, and there's a back loop that goes down low, so don't mess those up. That's simple. Hope you guys enjoy the video with it and learn something from it.